Hey everyone, I'm Bill. I'm the marketing videographer here at Neo. I've been here for a little over a month, and a lot of that time I've spent trying to understand what Neo is and how it works. But I found it's actually very easy to understand. I just had to find the right person to draw it out for me.
All right, what is Neo? First up, Neo is a programming language, a platform, if you will, for building, designing, deploying, and reasoning about distributed systems. How do a bunch of individual machines communicate and talk with one another, pass messages around? It's effectively what Neo is. How does it work? I guess to get into that, we really need to talk about three assumptions that Neo exemplifies or Neo implements. One, everything is a signal. Two, systems are distributed. And three, Neo is agnostic. And to go through sort of like what each one of these means, everything is a signal means that all the data that Neo deals with can be encapsulated in what we call a signal. Just basically a little container, a little box that you can put information into. So you got some information, you got ones and zeros. And you can put them in that box and then send that box through the system. Neo operates basically the thing that Neo consumes, the raw materials that make up a Neo system are signals. And they sort of flow through the system. They move around and do different things. Basically, we have this idea of a block. Blocks either consume signals, transform signals, or produce signals, send them out other places. So everything is a signal. Means that there's a commonality, a way that you can think about data as it flows through this system in the same way that you reason about just kind of shipping boxes around between different places. And how those boxes get changed, right? So I guess a classic example is, so say I got a box that's a square. So my signal's a square. I could push that into some sort of block that basically takes all squares and produces out triangles. And that's all this thing does. Basically sits around and waits for signals to come in that are square-like and pops out a little triangle block. Triangle signals. You can wire together really complex behaviors by connecting a bunch of different blocks that all do different things. Two, systems are distributed. This is an interesting one. For a long time in computer science, we've sort of reasoned about machines, computers, whether they be your desktop computer or a laptop, or a cloud instance, or even a Raspberry Pi, as individual things, right, that need to be programmed separate from one another. And there's lines between all of them. If we want to communicate between them, it's kind of a hassle, it's kind of a pain, pass messages around. Neo really is grounded in that principle on top of everything as a signal, that all systems are distributed. So a system really encapsulates a boundary that defines how signals flow through it. And we try to eradicate these lines, or at least abstract them away. So that when you're designing a system, when you're building how things should operate, you don't have to worry so much about the lines. You can just talk about the communication. Whew. Cap is on there. Talk about how data moves around. Free from barriers, right? 3, Neo is agnostic. Means that it's not really tied to any particular database or any particular type of sensor or any particular type of mobile device or any sort of computational container. That we strive to be as agnostic as possible. In that sense, I guess, coming back to that concept of blocks, you can have multiple types of blocks that all abide by the same interface and therefore are interchangeable depending on what you have available. So this might be an iOS accelerometer block. It basically reads accelerometer data from your iPhone. We can have an Android version. And we can have a Raspberry Pi version. And they all abide by the same interface. So that means that the signals that they produce all look the same, just where they came from are different. You can use those basically interchangeably within your service. Depending on where you're running or what you're doing or what device you're running on, you might pick each one of these blocks to provide that ability to give you that thing. We do the same thing around databases. We do the same thing, for sensor integrations. I'm gonna draw a little camera. We do the same thing for basic transformations, taking one type of block or one type of signal and turning it into another type of signal. That concept. So you build basically your system with these 3 tenets kind of in place, and it frees you up from having to think about sort of specific implementations of how those things work. Kind of got a little messy there. So coming back to this thing, what is Neo? It's really a way to think about legacy databases, cloud instances, or as many clouds as you have, multiple clouds, users in your system, people looking at a web page, people on their phone, and hardware devices, like I said, Raspberry Pis, various hardware integrations. Think about them in the exact same way. How do each one of these communicate with each other in a seamless environment? They can all talk to each other. And that is really what Neo is. Bonk. So where are we taking it? This is a fun one. So a lot of the platform stuff we already have working, we already use internally for our own projects and various customer integrations. So where we're really taking it is focusing on documentation. Basically, how do you learn how to build things? How do you learn to sort of shed your abstractions and shed your previous way of thinking about building computers, building machines, building programs that run on those machines, and how do you integrate it into more this style of message passing and tooling to help you deploy and maintain an existing service. I think I said that right? So you build whatever you're going to build. How do you send that out to the world?
All right, James, a real-world application that Neo is currently applied to or can be applied to.
So let's just start with a kid. So we got this kid. He's a happy little kid. But he's got diabetes, right? It's something that he has to manage, right? And right now, the way that people think about managing diabetes is to, do blood insulin tests at various times in the day to make sure that your blood sugar stays within tolerable limits and that you don't have problems. And I guess the system that I want to talk about today I really want to talk about more like the environmental aspects of Neo and how Neo can become what some refer to as ambient computing. And by that I mean we are surrounded by devices, computers, either phones, televisions, smart TVs, Alexa, home integration devices. Let's see what else we want to put in this thing. This is a TV. Computers, laptops, throw that on here. And right now, they all exist sort of like in their own little silos, doing their own stuff, basically all by themselves. And the idea of Neo, an application of Neo, how can I take all these different things, all these different devices around me, and have them cooperate, work together to fulfill a goal? And this goal is going to be to remind this kid to take his blood sugar and know that he's fine, right? So the idea would be in his house or any environment that he's in. This is a long-term goal. So if he's in his house, and he's downstairs watching TV, right, on the couch. There he is hanging out. And we install Neo as a system that integrates with all these different devices, that if we know that it's time for him to take his blood alcohol, or not blood alcohol, yoinks. It'd be interesting for that kid to have to take a blood alcohol test. But his blood sugar, we could send him a reminder on his TV, have a little pop-up notification that says, you know what, it's time for you to do this thing. I want to remind you, right? If he's in the kitchen getting cereal and the Alexa's in there, we could send him a notification through Alexa. If he's upstairs and hanging out in bed and we know he's got his phone, right? Using some location device, we could send the notification to his phone. Or ideally, if he's in any environment, right? He's at school. He's at school. Long term down the road, that we could basically opt in televisions, display devices in his classroom or wherever, doesn't really matter, and delegate that message to wherever he is, so that no matter where he goes, that system travels with him, right? And we're passing messages around between all these devices, and he has a smart connected blood sugar device that we can help move that data around, move that information around with signals to all these different places, and more effectively do it. And do it in a way that enforces his privacy, right? That we don't have this master cloud instance up here that sits around listening to everyone creepily, and everybody sends all their data up to that thing, right? That's not what we're talking about doing. We're talking about how can we build a system that integrates all these different devices together, but maintains that sort of privacy boundary, so that the data for this kid stays private where it belongs, right? That he can help integrate in all the devices and all the things around him that are smart, capable, more powerful than any computer I had growing up, and get them to work together, cooperate, to help keep this kid healthy. That's what they both want, right? That's what his parents want, that's what he wants, and that's really what we're trying to empower the machines to be able to do. It's a pretty succinct, in my opinion, way to talk about places that Neo could be applied in the household, in the world, to solve really big problems right now by, I guess, really taking back control of these devices that we have around us and helping them work together and work with us, right, to do the things that we want to do. I don't have diabetes, I wouldn't want to do this, but it's a great thing to work on, right? It's a great thing to help other people be able to do.